CS 3351 Digital Principles and Computer Organization. Topic is interrupts. Presented by Devi Visalaksha, Assistant Professor of CS Department, Rohini College of Engineering and Technology. Interrupts. An interrupt is signal to the processor emitted by hardware or software indicating an event that needs immediate attention. An interrupt alerts the processor to a high priority condition requiring the interruption of the current code the processor is executing. There are two types of interrupts. First one is the hardware interrupts and second one is the software interrupts. So hardware interrupts. Hardware interrupts are used by devices to communicate that they require attention from the operating system. Internally, hardware interrupts are implemented using electronic altering alerting signals that are sent to processor from external devices, which is either a part of the computer itself, such as disk controller or an external peripheral. A software interrupt is caused either by an exceptional condition in the processor itself or a special instruction in the set which causes an interrupt when it was executed. Interrupts handling. The interrupt mechanism allows devices to signal the CPU and to force execution of a particular piece of code. When an interrupt occurs, the program counter's value is changed to point to an interrupt handler routine that takes care of the device. The interface between the CPU and I/O device includes the following signals for interrupting. The I/O device asserts the interrupt request signal when it wants service from the CPU. The CPU asserts the interrupt acknowledgement signal when it is ready to handle the I/O device's request. This one is the interrupt mechanism diagram. So here it's having the CPU as well as a personal computer, and then it's sending the interrupt acknowledgement to the device. So it's having the status register, data register, as well as the device mechanism. So it's having the first it will send the request, and then it will send the interrupt acknowledgement, and then it will be transfer the data in both sides. It will send as well as receive, as well as this device also send and receive. Priorities and vectors. So interrupt priorities allows the CPU to recognize some interrupts as more important than others. Interrupt vectors allows the interrupting device to specify its handler. The priority mechanism must ensure that a lower priority interrupt does not occur when a higher priority is being handled. The decision process is known as masking. Asking an I/O device whether it is finished by reading its status is often called as polling. The highest priority interrupt is normally called the non-maskable interrupt. Most CPUs provide a relatively small number of interrupt priority levels, such as 8. When several devices naturally assume the same priority, you can combine polling with prioritized interrupts to efficiently handle the devices. The CPU will call the interrupt handler associated with this priority. That handler does not know which of the devices actually requested the interrupt. Vectors provide flexibility in a different dimension, namely the ability to define the interrupt handler that should service a request from a device. This figure shows hardware structure required to support interrupt vectors. In addition to the interrupt request, the acknowledgement lines, additional interrupts vector lines run from the devices. After the device's request is acknowledged, it sends its interrupt vector over those lines to the CPU. The CPU then uses the vector number as index in a table stored in a memory as that's shown in the figure. There are two important things to notice about the interrupt vector mechanism. The first device, not the CPU, stores its vector number. In this way, a device can be given a new handler simply by changing the vector number it sends without modifying the system software. For example, vector numbers can be changed by programmable switches. The second thing to notice that there is no fixed relationship between vector numbers and interrupt handlers. The interrupt vector table allows arbitrary relationship between devices and handlers. The vector mechanism provides great flexibility in the coupling of hardware devices and the software routines that service them. Most modern CPUs implement both prioritized and vectored interrupts. Priorities determine which device is serviced first, and vectors determine what routine is used to service the interrupt. The combination of two provides a rich interface between hardware and software.